everyone, and welcome back to these exponents lessons. And in this lesson we will look at rational exponents. Now rational exponents is when the exponents are fractions. Now this is what we do if we see exponents that are fractions. When we see rational exponents and big base numbers, for example 9 is 16, 0, 1, 2, 5, 8 and 4, well, they're not that big, but we can rewrite them in their product of their prime factors. Then we do that. So as soon as I spot rational exponents, I rewrite all my coefficients as a product of their prime factors. Okay, so easy enough to remember. Again, I'll say it again. When I spot rational exponents, that is exponents that are fractions, I rewrite the coefficients or the base numbers as product of their prime factors. Then I just apply my exponent laws. And remember, we can rewrite all of the following as product of prime factors. A 12 becomes a 2 to the power of 2 times 3. 16 becomes 2 to the power of 4. 25 becomes 5 to the power of 2. A 0,25 is a quarter, which becomes 1 over 2 to the power of 2, which is also a 2 to the power of negative 2. Because if I pluck that one with a positive exponent from underneath the fraction line, and I go put it at the top, well, then that sign changes of the exponent, right? Okay, great. So I hope you remember how to rewrite numbers as product of their prime factors. Your calculator can also do it just by pressing 12, press equal, press shift, press the button fact, and it gives you the product of prime factors. Now, let's go and look at the examples. Well, there's a rational exponent, so I'm going to take this coefficient or this base number and rewrite it into its product of prime factors, which will be a 3 to the power of 2, and 16 is 2 to the power of 4, right? And put it in brackets and leave that rational exponent on the outside. Multiplied by, this is an eighth, and then I rewrite the exponent on the outside. So basically, if we multiply this, this will become 3. 2 times minus a half will be a minus 1. And we write the 2, and then we can say 4 times minus a half, which is a minus 2. Times, and this will be 1 over 2 to the power of 3, because I can still rewrite an 8 as a product of its prime factors, and leave the minus 2 over 3 as the exponent. Well, then I can quickly swap these two around, which will then be 2 to the power of 2 at the top, 3 to the power of 1 at the bottom, and this will be 1 over, write the 2, 3 times minus 2 over 3, that will just give me a minus 2. Okay, so now almost done. I can say this is a 4 over 3 times, and then take this negative exponent and put it above the line, which is 2 to the power of 2 over 1. So this is 4 over 3 times 4 over 1, which is 16 over 3. Okay, great. So when we have rational exponents, we rewrite all the bases as product of their prime factors, and there are the different ones, right? And then we just follow our normal exponent laws and sometimes the definitions as well. Okay, I didn't use my calculator. I solved this entire problem without my calculator. Just by remembering that if I have rational exponents, I rewrite the bases as a product of their prime factors. Now again, there is a rational exponent, so rewrite that 8 as a product of their prime factors. I don't need to do it with the 4 because there's no rational exponent that deals with the 4. So I'm just going to say that this is a 2 to the power of 3, a to the power of 6, b to the power of 12. Put it in brackets, leave the third on the outside, and at the bottom we've got 4ab to the power of 2. Now here's the exponent law. We simply write the base, we write the 2, I write the a, I'm just going to do this quickly, and then it's 3 times a third, which will be a 1, then it's 6 times a third, and that will give me a 2, and then we have 12 times a third, which will give me a 4, right? Okay, so write the 2, 3 times a third is 1, write the a, 6 times a third is 2, b, write the b, 12 times a third is 4, and then we divide with 4ab squared, and now we have a division sum. So 2 goes into itself once, it goes into 4 2 times. And as I do that, I always just go and I write it down as I cancel out. There's 1a. If I take 1a away there, I need to take 1 at the top. 2 minus 1 is a 1, so a remains at the top. If I take 2 b's here, I need to take 2 there, and b to the power of 2 remains there. And we have 1a to the power of 1, b to the power of 2 over 2. There's another way of writing it. It's just a half ab squared, because all of that is at the top. It's only the 2 at the bottom. Okay, great. And that is easy, isn't it? So don't forget, if we see rational exponents, take the big bases and rewrite them, or all the bases when we see rational exponents, and rewrite them as a product of their prime factors. Now let's go and try some more examples. Here are 2 examples that you can try. Give them a go, and once you are ready, resume the video to see if you are correct. One little hint, please rewrite all mixed fractions as improper fractions. Okay, give them a go. Now here I go, so if you aren't finished yet, just pause the video, resume your work, and once you are done, just resume the video to see if you are correct. Now 3 and 3/8. If I want to rewrite this mixed fraction as an improper fraction, can you remember how? 8 times 3 is 24, plus 3 is 27 over 8. Okay, so we write 27 over 8, and we still have minus 2 over 3 on the outside. If we have rational exponents, rewrite the bases as products of its prime factors. That will be a 3 to the power of 3. This will be a 2 to the power of 3. And then basically we have the minus 2 over 3 on the outside. And now what do? We simply multiply that exponent with that one, and this exponent with that one. So I write the 3, and then 3 times a minus 2 over 3. Okay, and that will give me a minus 2. And at the bottom 2, and then we have 3 times minus 2 over 3, which gives me a minus 2 as well. And that equals 2 to the power of 2, 3 to the power of 2 equals 4 over 9. And look, this was the definition. I don't want the negative exponent. It goes to the top of the line. This one also has a negative exponent. It goes to the bottom of the line. It's not a swap around. I pluck the base that has a negative exponent, and I just go put it below the line if it was above the line. I take this exponent that is negative with its base, I pluck it out there, I go put it above the line, and the negative exponent becomes positive, and then I just simply simplify what's left. So 2 to the power of 2 is 4, 3 to the power of 2 is 9. Okay, great. Now, how about this example? Again, I see rational exponents. So if I do that, the big bases, or any bases that are numbers, I rewrite them as a product of their prime factors. So this will simply become a 3 to the power of 3, m to the power of negative 1. And look, I'm not doing any calculation yet. I'm simply rewriting it as a product of its prime factors. So a 81, that will simply be a 3 to the power of 4, right? So 3 to the power of 4, and you know how to check for that. You can either use your calculator, you can set up that little table that you used to learn in grade 9, and then this is m to the power of 2, leave it in brackets with the minus a half. Okay, great. Now, since we have a fraction here, we always want to simplify the numerator as far as possible and the denominator. So I'm going to write the 3, and then I'm going to say 3 times a third, which is to the power of 1. Write the m. Then it's minus 1 times a third. That gives me minus a third. Okay, wonderful. Times, and we write the m, and then we will say a third times 4, which will be 4 over 3. And then at the bottom we have, write the 3, 4 times minus a half, that's minus 2. Write the m, 2 times minus a half, which is a minus 1. equals, I can still simplify here at the top because we want to simplify the numerator as far as possible, and this is multiplication. So 3 times a 1, which is the coefficient in front of that m, is a 3. And then we want to multiply the m with the m. So basically I write the m, and then it is minus a third plus 4 over 3. And if I have minus a third plus 4 over 3, I get m to the power of 1. Okay, great, because this is 1 and a third. So minus a third plus 1 and a third just gives me a 1. And at the bottom, we still have a 3 to the power of negative 2, and we have m to the power of a negative 1. And now I don't want negative exponents, so I have to move all of them. Okay, so this will basically be a 3 times, and then it will be a 3 to the power of 2. I write the m to the power of 1, and then this m at the bottom also goes to the top, which will be a m to the power of 1. So this is just multiplication. So 3 times 9, that gives me a 27, and I've got m. 1 plus 1 gives me a 2. And that is my final answer. So I hope you could follow what I did here. It's not that hard though. So just remember, this 3 to the power of negative 2 goes to the top, and then we have a 3 to the power of 2, which becomes a 9, and then it will be 3 times 9, because I took everything at the bottom because they have negative exponents, so they all go to the top. So it's everything at the top over 1, which is just everything at the top, right? Because everything there over 1 is just everything. Okay, so don't forget that. When we write any number over 1, it's just that any number. You know that, right? So let me just show you. 2 over 1, it equals 2. If you say 27 over 1, it equals 27. Okay, you remember that from a long time ago. So that is the final answer. So what do you have to remember in rational exponents? Simply take your base numbers and rewrite them as a product of their prime factors. And when you have one like this that is a mixed fraction, rewrite it as an improper fraction, and then find the product of the prime factors of the numerator and denominator. And you will most of the time see when you multiply them out, the rational exponents will disappear as you continue with your exponent laws. Okay, wonderful, and I hope to see you again next time. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.